1 cm square tiles and rectangular tiles were used to make some figures. When they say 1 cm square tiles, meaning to say every side is 1 cm, all right, each side of the square. The area of each rectangular tile was half that of a square tile. Okay, so every triangle is half of a square, and the first four figures are shown. All right, so we have a table provided for part A. We're supposed to fill up the table. All right, so when you have patterns question, whenever the question, let's say if they did not give us a table, right, what we should do first is to try to create a table. Okay, to create a table that shows your figure number and the number of triangles, number of squares, all right. Area of figure may not be necessary. Let's say you're creating your own table, all right, but since it's already provided here, which means that we likely would need this later on as well. All right, so question already have already provided our table. Let's look at the numbers first. For number of triangles, if you go down the row, you notice that 1, 4, 9, 16, right? What kind of numbers are these? So this should strike you as square numbers. Okay, if you notice that actually, I know typically most of us, when we do patterns, we usually try to observe the increase. Then you observe this is like a +3, this is like a +5, this is like a +7. Okay, but you notice that the increment is not constant. All right, in fact, it's like an increase upon another increase because this is an increase of 2, right? So it's not going to be sustainable if you are going to solve for your later parts of the question, say part B, part C, right? So actually, if you are familiar with your patterns, you should notice that 14916 are actually square numbers. So what are square numbers? So square numbers are simply numbers that is made up of a product of two numbers that are the same. Okay, meaning to say 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Right? Okay, so that's the pattern that you see here. So basically, it's actually the figure number times itself again to get the number of triangles. Okay, so 2 times 2, figure 3 times 3, figure 4 times 4. So of course, the last one will be figure 5 times itself, 5 times 5, which is 25. Okay, let's move on to the squares. So for the number of squares, we see there's 0, 1, 3, 6. Right? So the pattern here is if you go down the row, you notice that it's an increment of 1 plus 1 plus 2 plus 3. Okay, and of course, the next one will be a plus 4. Again, this is not a constant increase, right? However, if you notice that the increment in terms of the numbers is easier to work with, it's just 1, 2, 3, 4, and it goes on consecutively, right? So this will be 10. Next, area of figure in terms of square centimeters. So area of figure, if you look at all the figures, they are actually all triangles. Okay, the whole of figure 1 is triangle. Same for figure 2, this whole thing is a triangle, and this whole thing is also a triangle. All right, so use the diagram to help you avoid doing this. All right, I know again you would probably sense this plus 1.5 plus 2.5, okay, plus 3.5. All right, I'm not saying this is wrong. I'm not saying this is wrong. All right, however, it would be better if the diagram could be an advantage for you to observe. Is there a quicker and more efficient way to get your area of figure? All right, why is that so? Because if you look at your part B question later on, this way of doing is not going to be sustainable. All right, so since the diagram is there, the diagram should be able to tell you some information about how to get an area of figure. And what we know about area of triangles, half times base times height. Okay, so let's say if I use figure 3, you observe that figure 3, my base and heights are 3 centimeters each. Correct? Because the question clearly says 1 cm square tiles. So this will be 3 cm, this will be 3 cm. So if you notice, figure 3 to get 4.5 area is actually half times 3 times 3, half times base times height. Okay, same for figure 4. 4 cm here, height, 4 cm base. So again, half times 4 times 4 will actually give us an 8 cm square here. All right, so notice the pattern is, it's actually half times the figure number times the figure number. Same for this, half times figure number times figure number. So if you like to find out the blank here for figure 5, the area will be half times, since it's figure 5, so half times 5 times 5, which is 12.5. All right, so we have established that finding the area for each figure number would be just half times that figure number times itself again. And with that in mind, we can go on to do part B. So part B, this time they ask how many squares were used to make a figure with an area of 180.5 cm squared. All right, so again, this is what I mean. It's not going to be sustainable if you're going to just keep adding all the way until you reach 180.5 cm squared. All right, that shouldn't be the right way to solve. Okay, you got to look out for more efficient ways, and which is what we agreed on. The area will be half times figure times itself. Half times figure times figure. So what I can say is that this area, half times some figure number, equals to the 180.5. So half times this equals 180.5. So lay out this equation first, and you realize that by looking at this equation, it's easier to go on to know what to do. All right. So how do I know what to do next? So notice that because I have this half here, I have this 180.5, I can find out this value. That means the product of the figure times figure. How do I do that? Simply just 180.5, you can divide by half. Or you can take 180.5 times 2. It's the same thing. Okay, so you can divide by half or times 2. Both will give you the same answer. Okay, why times 2? Because I want to get rid of the denominator 2. Alright, so basically you times 2 to the left-hand side. That's how you get rid of the half. You times 2 to the right-hand side as well. So 1 is 0.5 times 2. Okay, if you find this confusing to understand, you can just simply divide it by half because this is product. Opposite of product is a division. Alright, so that means figure times figure. Now I've figured out that this product is 361. Now, and we know that these two have to be the same numbers. So something times something give you 361. So this is what we know already. Something times something give us 361. So to figure out what is these two numbers, which is the figure number, you can simply use a square root function. Square root 361, and you key in your calculator, you should get a 19. So now I know this is 19, this is 19. That means my figure number would be figure 19. Okay, so once I've reached figure 19, all right, now we can now focus on the squares. At least now I know which figure I need to focus up to. Then you focus up to figure 19. And if you look at the squares pattern, notice that notice that the squares is from 0. Okay, we start with 0 squares from the first figure. And actually you keep adding down, and your addition keep increasing by 1. So 0 plus 1, then plus 2, plus 3, plus 4. All right. So this is the pattern that we are going to follow. I'm going to circle this up. I'm going to highlight this in pink. This is the pattern that we would like to follow. This one. Okay, because it's just consecutive addition of numbers that increases by 1. All right, and if you're wondering how are we going to do this, are we going to keep doing the addition until we reach figure 19? No, we're not going to do that. All right, so let's learn a way that how to quickly add to find the sum up to figure 19. All right, so to do that, before you do that, all right, I need you to observe something first. Now, we're starting from 0 squares. And if you notice, to reach figure 2, I plus 1 to it. To reach figure 3, I plus 1 plus 2. To reach figure 4, I plus 1 plus 2 plus 3. Notice that the last number that is added to 0 is always 1 less than the figure number I would like to arrive at. Okay, so this is what I mean. You see, to reach figure 2, you plus 1. To reach figure 3, you have to plus 1, then plus 2. So plus 2 was the last number you add to reach figure 3. If I reach figure 4, my last number to add to 0 is plus 3. Okay, so this is what I mean. You see, your last number that you're adding to your addition equation is always 1 lesser than the figure number you want to arrive at. So what does this mean? That means if I want to arrive to figure 19, I need to plus all the way until 18, one less than figure 19. So 0 plus 1 plus 2 plus 3 plus all the way up to plus 17 plus 18. Okay? So this is your key to working out your number of squares at figure 19. Now, but are we going to do this addition? All right, so many numbers to add. Are we going to key in calculator all the way to plus 18? All right, you can, but not the best way. Because what if I give you a question that compels you to plus all the way until 100 or plus 200, even bigger numbers. All right, you don't have all the time in the exam, so please learn it the right way. So I'm going to teach you how to find the sum of such consecutive numbers. So to do this, all right, what we are going to do is we are going to write this series. I call this a series. We're going to write this series in 2 rows. So this is my first row, and in my second row, I'm going to write it in such a way that it's in the reverse order, like this. Notice that? Okay, it's in the reverse order. Now, why am I doing this? Because if you notice that by doing this, you realize that there is a consistency in value in the sum of each pair of numbers. So I've circled one pair of numbers. Notice that the next pair, it gives you the same sum. This also. Notice that throughout the sum is always 18. Okay, so that means I can say that one pair, the sum of it is 0 plus 18. Or you can use 2 plus 16, 1 plus 17, doesn't matter. At least now we know every pair gives us a sum of 18. Now, my next thing is, how many pairs are there? There are actually 19 pairs of numbers. How do I know there are 19 pairs? Because 0 to 18, there are 19 sets of numbers. Be careful, not 18. It starts from 0, so you have to include that. All right, if it's 1 to 18, then of course it makes sense, it's 18 numbers. But if it's 0 to 18, that's 19 numbers. If there are 19 numbers throughout here, that also means there are 19 of such pairings throughout this whole thing. Okay, I hope I'm clear on this. So to find out the sum of 19 pairs, simply take the sum in one pair times 19. So now I know throughout this whole thing, all 19 pairs of numbers throughout these 2 series has a sum of 342. Meaning to say that everything here adds up to 342. Okay, now the next is, how am I going to work around this 342? So this 342, notice, is actually the sum of these series as well as these series. The 2 series I boxed up in purple adds up to 342. Why? Because the 2 purple series was bundled together by the 19 pairs. I've circled in blue the 19 pairs together. That also means the sum of the top 2, the 2 series here. No, but because we're only interested in one of the series, number of squares is just the sum of 0 to 18, just one of it. That means I can safely use 342 and divide it by 2. And that means each series has a sum of 171. And that's it. That will be my number of squares that I'm looking for.